The European Union has given providers of AI an ultimatum of 2nd of August 2026 for them to ensure that there's transparency when it comes to AI-related content. And what this means is that content that are generated by AI must be marked as AI generated. There are two major types of content that will be watermarked. First is images and files, and those category of content will be watermarked by signing their metadata using a standard called C2PA. It's already established in the industry, so the signature travels with the file whenever you share it. While the second thing that will be watermarked is text. And for text, the pattern lives in the word that is chosen. Is the text itself. The watermark is the text itself. It's not adding something extra to it. But how will that work? Well, let's find out. Let's consider this word, for example. The cafe on the corner serves the best. Well, to you it might be obvious what should come next, but to the computer, it's not so obvious. It considers different possibilities. Like, for example, there's coffee, and that has a higher chance of coming next, which is at 42%. There's also pastries, and pastries has a 23% chance of coming next. There's espresso at 16%. There's breakfast at 11%. There's tea at 8%. Well, the model doesn't just go ahead and pick the highest probability, which is at 42%. No, it doesn't just do that. What it does is sort of like spins a wheel. Let me just make a random choice, basically. So it goes ahead, spins that wheel, and then it will just tell you, it will just pick the word where the wheel lands on, something like that. It's just making a random choice. It could have been pastries, it could have been tea, but in our case, it landed on coffee, so coffee would be the one that come next. So, and it will repeat this continuously for every word until it completes the entire text. SynthID is the technology that Anthropic is basing their watermark on. It was developed by Google, and it introduces two things before a word is being chosen: a random seed generator and a sampling algorithm. The random seed generator just helps us to get a seed, while the sampling algorithm helps us to choose the next word. Let's look at the random seed generator because this is very important in the watermark process. First, we need a key which only Anthropic will know, and the key looks something like this, okay? 9F2C, something like that. Only Anthropic knows this, or the model provider knows this. There's something else that Google recommends, a hash of the last few tokens. In Google's paper, they recommended the last 4 tokens, right? Let's take the last 4 words in our example. Corner serves the best, okay? So Google is going to take those corner serves the best and basically combine it with the watermarking key to generate a seed. Now, this seed is reproducible. Anytime we combine our watermarking key and these last 4 tokens, we'll get this exact same seed. And that is why we can detect later. It's very, very important. The watermarking key plus the last 4 tokens give us the random seed every single time. Okay. Now that we have the random seed, the next step that we will introduce is the sampling algorithm. Instead of just spinning the wheel and choosing the next word, Google recommends we introduce a sampling algorithm. Companies can choose whatever algorithm they want, but Google recommends tournament sampling. How would that work? First, we need watermarking functions. These are what we call watermarking functions. Well, the coffee, the pastries, the espresso, the breakfast, and the tea, if you are familiar with that, those are the possibilities that the model is considering. Then Google recommends that we come up with these things called watermarking functions. Each word is given a score between 0 and 1. In Google's paper, the rounds they used consistently was 30, but for simplicity, we'll use 3 here. Okay, so we just have these watermarking functions, basically 0 and 1s for the different words. The seed is the one producing these watermarking functions. That same seed that we saw here, this seed is the one producing these watermarking functions. And it's quite important what it does. Basically it's giving zeros and ones to the different words, okay? There's just some combination it has done in its head and gives 0 and 1, 0 and 1, 0 and 1. And it will do that for the different rounds, okay? It's also very important as we'll come back to, okay, how does it help with detection? We'll come back to it later, right? But we have different rounds that these words have to go through before they eventually get chosen. So let's look at the round. For the tournament sampling, Google recommends that we start with a tournament of 8 tokens, then we move our way up to the last person. It's just like football, where we start with round of 8, then round of 4, then round of 2, like that. Okay, so first we need 8 teams, right? Or 8 tokens. So we spin the wheel the first time, and when we spin it, we'll get the first word, which is pastries. And then we spin the wheel again, and we get the word coffee. So we go through that spin again, we get coffee versus espresso, we get coffee again versus coffee, we spin again, we get pastries versus breakfast. Well, we now have 8 teams. Now, after we've generated all the 8 teams or the 8 different tokens, then we need to eliminate some of them so that we have a round of 4, right? So now, how do we do that? Well, we use the watermarking functions that we generated previously. I'm going to put it on the screen now. These functions, we have the watermarking functions for round 1, we have the watermarking functions for round 2, we have the watermarking functions for round 3. Now, we need to start scoring it. So, we look at pastries. Pastries has a value of 1, coffee has a value of 0. So, for the first pair, pastries win. For the second pair, coffee and espresso, 0 and 1, espresso win. Coffee and coffee, we choose anyone at random. We have coffee, pastries and breakfast, pastries and breakfast, pastries win. For round 2, we basically just pair them together, pastries versus espresso, coffee and pastries. If we look at our watermarking functions, pastries and espresso, espresso wins. Coffee and pastries, coffee wins. Okay, so that's why we have this. Then espresso and coffee move on to round 3. So for round 3, we have espresso versus coffee, and coffee wins. So this is how we eliminate until we get the winner. So now the word now becomes the cafe on the corner serves the best coffee. Okay, then we'll continue like this until we finish our text. So that's the method that Google introduces with SynthID. So how then do we detect this? To detect the watermark, what we need is the watermarking key. Then once we have the watermarking key, you just paste in the text you want to check if it is generated by an LLM, Claude, Google or not. Okay, so just paste it in there. Once we have the watermarking key, then we can detect. But how? First, we use the watermarking key and we combine it with the last 4 tokens. Okay, so we definitely cannot start at the first token. We'll start like at least 4, or depending on the number of tokens that the company is using to do this, to generate this random seed. Remember, this seed will always be the same so long as we have the watermarking key and the last 4 tokens. So what will this do for us? Well, it will basically generate the watermarking functions for us all over again. Those zeros and ones for the different rounds that we compute, all of that is what's going to give us a gain. Okay, it's not useful to us, so the computer will definitely not show us this. So, but this is what it will go through internally inside of a calculation. So for the word D, these are the watermarking functions. If it's more than 3, maybe 30 of them. For cafe, these are the watermarking functions for cafe, all 30 of them, or in this case 3. Okay, and all the way to the last word. Now, if you notice when we're doing the watermarking functions, if you notice, the words that have more ones tend to win. Like coffee, it had 2 1, so it won. Okay, it won over espresso. If you have more ones, you usually tend to win. We can definitely confirm that if a text has more ones in it, then it's probably it was probably favored during the tournament sampling. Okay, so now what we then do is we just basically count these ones that we have here, okay, as against to the zeros that we have here. If the entire text tend towards the favored side during the tournament sampling, then we can reasonably say that this was generated by us. A normal text will probably have a balance between zeros and the ones, maybe like a 50-50 split, a 49-51 split, right? Not very different. But something watermarked by an LLM, we have an higher percentage of ones over the zeros. The company will set a threshold, for example, 75%. Any text that has over 75% more ones was definitely generated by us. If we count number of ones here, we'll see that we have 22 ones out of 27 ones are up 81% over the zeros. Let's say our threshold is 75%. Well, because you had above that, then we can say this was watermarked. Could we be wrong? Yes, we could be wrong. The detection is not infallible. We could be wrong. So if an human being chooses words that would have been favored within a tournament sampling round throughout an entire text, then we would be wrong. But it's very unlikely that that happened over a long piece of text, okay? But yes, we could be wrong. There could be false positives. And also, an human being can write so well that the machine will not be able to detect if it was AI generated or not. Also, can we trust that this approach will work? Yes, we can trust that it will work because Google says that they've tested it on their models and people did not notice any difference in it. And because we are watermarking the text, it doesn't mean the model choose the wrong words. Then you don't need the model again once you are detecting. It's only that selection process that changed. We did not change how we are training the model at all. And so it works at scale. We can use it over a large number of text. It won't be computationally expensive to do because it's just that process where we're choosing words that we introduce something new such that we can be able to detect words that were generated later. So that is how we watermark text. And I hope you learned from this. Like and subscribe. I hope to see you in another video.